see this a lot with people using simplistic one-dimensional software. Imagine you have a setup like this. This is a tank with a reasonably high pressure, with a very light gas at a moderate temperature, and a building behind it. And let's assume the free stream, the wind direction, is generally as shown from left to right on the page. So if you have a breach in this location, what they tell you is that if the gas is heavy, it's going to sink to the ground. If the gas is neutrally buoyant, it's going to stay at the same elevation in which it is released. And if the gas is light, then it's going to be lifted up, and fly away and not give you a problem. So they're basically assuming that the free stream looks like this. So everything is traveling uniformly in the direction. If you have a release, the buoyancy will just lift it up. The reality is very, very different. Some of the gas is lifted up. Some of the gas impinges on obstacles and drops downwards to the ground. And then if it's still light enough, will start to rise again. But most importantly, if you take a look at the evolution of the flow around the building, you will see that there are vortices forming. Vortices are these circular structures of flow, which you can clearly see in even a very simple case like that. Part of the vortex drags the gas upwards, and part of the vortex brings the gas downwards. And even in a simple case like this, you can count 1, 2, 3, 4, 5, and a couple others that you can't see. So the net effect of this is that even if gas is light, the vortices can bring some of it back down. And that's why you see ground level gas detectors going off some distance away from a release of a buoyant light gas, because people aren't taking into account these vortices that are dragging the gas back down. Obviously, without accounting for obstacles, you will never capture these vortices, and you're going to miss the effect entirely. Does your software do this? Do your consultants understand this? Chances are, no.